All right, let's talk about Kubernetes. You've probably heard the name. It's this incredibly powerful open source platform that has totally changed the game for managing applications at a massive scale. You ever wonder how these giant, complex apps you use every day just stay online? Well, a lot of the time, Kubernetes is the magic behind the curtain. So let's pull back that curtain and see how it all works.
It all boils down to this one problem that starts simple but gets complicated fast. Running a single container? Piece of cake. But what happens when your app gets popular and you need hundreds, maybe thousands of containers, and they all have to talk to each other, scale up and down, and stay healthy? Suddenly, you're facing this just monumental challenge. How do you possibly manage that kind of chaos?
Well, the answer is a concept called container orchestration. Honestly, the best way to think about it is like a conductor for a massive orchestra, but instead of musicians, you have software containers. It automates the whole shebang: deployment, scaling, networking, you name it. It makes sure all those moving parts are working together in perfect harmony. So here's how we're going to break this down. First, we'll dig into that core challenge. Then, we'll build up from there, looking at how Kubernetes actually runs your apps, how they talk to each other and handle data, what the brain of the whole system looks like, and then, this is the good stuff, we'll get into some real-world, hands-on operational knowledge.
Okay, first up, the orchestration challenge. To really get our heads around how Kubernetes pulls this off, we have to start with the single most fundamental piece of the puzzle. And, it might not be what you think it is.
Now, this right here is probably the most crucial idea to grasp from the get-go. Kubernetes doesn't actually manage containers directly, no. It manages something called a pod. Think of a pod as a little wrapper, a logical host for one or more of your containers. It's a totally brilliant abstraction because all the containers inside a single pod share the same network, the same storage. It's like they're all running on the same machine. This idea, the pod, is the foundation for everything else we're about to talk about.
So we've got our fundamental building block, the pod. But how does Kubernetes use these pods to actually run your application? And, maybe more importantly, how does it keep it running exactly the way you want it to 24/7?
Well, it uses this really powerful layered approach. You, the user, you don't mess with individual pods. Instead, you talk to a higher-level thing called a deployment. You just tell it your desired state. You say something like, hey, I want 3 copies of my web server running. The deployment then creates something called a replica set, and its only job is to make sure there are always 3 pods running. If a pod dies, the replica set creates a new one, instantly. You just manage the goal, and Kubernetes handles all the messy details. Now, deployments are fantastic for most stateless apps, like your web servers. But they're not the only tool in the toolbox. What if your app needs a stable, predictable name and storage, like a database? For that, you use a stateful set. And what if you need a specific process, like a log collector, running on every single machine in your cluster? Well, that's a job for a daemon set. It's all about picking the right tool for the job. Okay, great. Our applications are running. But they're kind of useless if they can't talk to each other or save any data, right? So let's look at how Kubernetes handles networking and storage. Remember how pods can be created and destroyed all the time? Well, that means their IP addresses are always changing. So how do you reliably connect to anything? The answer is an object called a service. A service gives you a stable, unchanging IP address and a DNS name that acts as a front door for your pods. For traffic inside your cluster, you'll use a cluster IP, and if you need to expose your app to the outside world, you can use a node port, or even better, a load balancer if you're in the cloud. And for when you need to get even smarter with your web traffic, that's where ingress comes in. While a load balancer just gives you a single entry point, an ingress lets you create intelligent routing rules. You can say, hey, if the URL is api.example.com, send traffic to this service. But if it's website.example.com, send it over to that other service. It's incredibly powerful stuff.
Kubernetes handles storage in this really clever, abstract way too. It separates the request for storage from the actual physical storage itself. So a cluster admin will set up some storage and make it available as a persistent volume, or PV. Then your application comes along and says, hey, I need some storage, by creating a persistent volume claim, or PVC. Kubernetes then automatically hooks up that claim to an available volume. It's awesome because it makes your storage setup portable.
So, we've seen all the cool stuff Kubernetes does. Now it's time to peek behind the curtain and see the components that make all that magic happen. Let's talk about the control plane, the brain of the entire operation.
It really comes down to 4 key players. First, you've got the API server. It's the front door. Every single command you run goes through it. Then there's etcd, which is the cluster's database, the single source of truth for everything. You have the scheduler, which is like a matchmaker, figuring out the best node for every new pod. And finally, the controller manager. This is the engine that's constantly working, trying to make the real state of the cluster match the desired state you've defined in etcd.
And the way the scheduler makes decisions is just super clever. It's a three-step process. First, it filters out any nodes that just can't run the pod. Maybe they don't have enough memory or CPU. Then, for all the nodes that are left, it scores them based on a bunch of rules to find the absolute best fit. Finally, it makes the decision and binds the pod to that highest scoring node. It all happens in a flash.
All right, knowing all the theory is great, but in the real world, things go wrong, because, they always do. This next part is all about the practical stuff you need to know to keep your applications humming along smoothly.
So to keep an eye on your app's health, Kubernetes uses things called probes. A liveness probe basically asks, hey, are you still running? If it doesn't get a good answer, Kubernetes restarts the container. A readiness probe asks a different question. Okay, I see you're running, but are you ready to serve traffic? If not, Kubernetes temporarily takes it out of the rotation. And the startup probe, well, that's for those slow-starting apps, to give them time to get going before the other probes kick in.
The dreaded crash loop backoff. You will see this error, I guarantee it. It means your container is starting, crashing, and then restarting over and over again. It's one of the most common issues you'll run into. So, what do? Here's your troubleshooting playbook. First thing, you describe the pod. That'll tell you why it last exited. Next, and this is usually where you find the answer, check the logs. The application itself will almost always tell you what's wrong. If that doesn't work, double-check your configurations. And finally, make sure you don't have a liveness probe that's too aggressive and is killing a healthy container that's just a bit slow to start.
And here's another classic, image pull back off. This one's pretty self-explanatory. Kubernetes can't download your container image. 9 times out of 10, the fix is super simple. Check for a typo in the image name. Make sure the node can actually connect to the image registry. And if you're using a private registry, just double-check that your image pull secret is configured correctly.
And one last, but really critical point on security. Kubernetes has this amazing system for permissions called Role-Based Access Control, or RBAC. It lets you get incredibly specific about who can do what to which resources and where. If you're running a cluster with more than one person or team, this is absolutely essential.
And just to put all this into perspective, this technology isn't even that old. Kubernetes first came out of Google way back in 2014. In just a handful of years, it's gone on to become the undisputed king of container orchestration. It's pretty amazing.
This quote really just nails it. At its core, Kubernetes is what's called a desired state machine. You declare what you want reality to look like, and Kubernetes works relentlessly 24/7 to make it so. It automatically restarts, replaces, and reschedules containers just to keep your application running exactly how you defined it. So we've seen how Kubernetes is this incredible system for managing the state of our applications, which of course leads to one final big question. If Kubernetes manages our applications, what manages Kubernetes? How do we keep track of our cluster configurations and automate their management? Now that's a whole other topic for another day, but it's where this journey continues. Thanks so much for joining me.